This is the Thermochemistry packet, worksheet 5, part 2. So I am on the second page of worksheet 5 in the Thermochemistry packet right now. And hopefully you've already done through problem 12 on this worksheet. The first video, the worksheet 5 part 1 video, explained how to do the first 12 problems. And in all of those previous problems, you were using the same basic equation that said you could solve for heat, which is measured in joules or kilojoules, depending on the amount of heat, is equal to mass times specific heat, I'm going to abbreviate specific, times the change in temperature, which we symbolize delta T or triangle T. So every single time you were given information about mass, you were told the specific heat of the material, or if it was water, you knew it was 4.184. And also you were told the starting temperature and the ending temperature, so you could calculate the change in temperature. So the only difference in the following problems is that we are going to use algebra to manipulate this initial equation to solve for either mass or specific heat or change in temperature. And if you're not really thrilled about the idea of algebra, the algebra has already been done for you. And these equations, the original and these three that I'll introduce now, will be provided for you on tests and quizzes. So you don't need to memorize or know how to create these equations, you just need to be able to use them. So if we solve the original equation up here for specific heat, we get that our first sort of version of the equation, which says specific heat, remember the symbol for that is a big C and a little p, is equal to heat divided by mass times the change in temperature. So if we put that into symbols, it's saying the exact same thing. Remember, specific heat is Cp. Heat, which we measure in joules, is a big H. Mass is M, and change in temperature is delta or triangle T. Second equation that you'll be using in the remainder of the problems just solves the same original equation for temperature change, delta T. So heat divided by mass times the specific heat. And the exact same equation, just in symbols. Delta T is equal to H divided by M times Cp, our symbol for specific heat. And then our third equation, we can solve for the mass of the material, which we measure in grams, right? When you see mass, it means grams. When you see grams, it means mass. They're interchangeable. All right, just like if I ask you how much you weigh, you're going to answer in pounds. Pounds is the unit for weight, grams is the unit for mass. So this is heat divided by the change in temperature times the specific heat. And again, same equation, just in symbols. M equals H divided by delta T times Cp. All right, so if we look at an example, right, this example is asking you to calculate the specific heat. So if we're trying to solve for specific heat, we want to use this first version of the equation up here that solves for specific heat. And they give you a number in joules, a number in grams, and two numbers in degrees Celsius. So I would make note, so that you can sort of pick out these numbers and identify where they go in the equations, right, that heat, H, is always going to be measured in joules, or sometimes kilojoules, kJ, right? And so this would be the number that we plug in this problem for heat in the equation, which is why we have it right here on the top of the equation. And when you see grams, that's measuring mass, right? So mass, which is symbolized with an M, is always measured in units of grams. So that's why this 25 number is put down here in the bottom of the equation. And then temperature which in this case is always the change in temperature, is going to be in degrees Celsius. And they'll usually give you two numbers, right? And remember, you always do the bigger number, which in this case would be 55, minus the smaller number, which is 40. Also remember, it's really important so that once you've put these numbers into the equation, you get the right answer. For order of operations, the first thing you need to do is do the subtraction of the temperatures. So 55 minus 40 gives you 15. And now you're ready to do 48 on top divided by the 25 times 15. And I'd probably put 25 times 15 in parentheses in your calculator. You can play around with your calculator and see how that works in terms of order of operations, but I would try actually putting that into your calculator and making sure you get 0.128 as your answer. Okay, now units are kind of funny here, okay, but you've got joules on top, right, and you've got grams and degrees Celsius on the bottom. So sure enough, my units are just joules on top and grams degrees Celsius on the bottom. That's actually the standard unit for specific heat, which I get it, it's weird. Okay, but that is what it is. All right. So, in example 2, this time they're not asking us to calculate specific heat like in example 1, but they want us to calculate the temperature change. So in this case, we would use the equation number 2, version of the equation number 2, that solves for delta T, change in temperature. So, they're giving us joules, which we know is really heat, or H, in our equation. They gave it to us in scientific notation, right? You could either leave this in scientific notation, if you can put in your calculator like that, or this is the same as 3,220 joules if you take it out of scientific notation. All right, our mass, M, is 35 grams. And we're talking about water. Now this can trip people up sometimes because they're thinking, okay, well the other thing I need for this equation still is specific heat, right? And they haven't told me specific heat. But we should know, and this number will be provided to you on tests and quizzes, it's in worksheet 3 of your packet, the specific heat of water is 4.184, right? So that's why on top we've got the number of joules. Oh, and this is a typo. That 0 should not be there. It's just 3.22 times 10 to the third joules. That's what was in the problem. And we're dividing by the mass times the specific heat of water, which is a constant number that we can look up. All right? And here is our answer, which I just rounded. Instead of saying 2.1988, I just called it 2.2 times 10 to the 1. Degrees Celsius. So don't think that's times 10 to the 10, right? That's times 10 to the first power. So in reality, we do not need scientific notation here. We can just call this 22 degrees Celsius, which is the same as 2.2 times 10 to the first power. All right. So one more example, and then I'll let you guys take a look at the fourth example that's on the next page, because I think you'll really kind of get the hang of this. This one is asking what is the mass of this sample of zinc that we have. So we're going to use the third version of the equation. All right, so this time they give us a specific heat. You can always identify specific heat, CP, because it's always got these really weird units, joules per gram degrees Celsius. Okay, and here's our number of joules, so that's going to be the H, the heat, and here is our change in temperature. So the number of joules goes on top of the equation. That's the heat. On the bottom of the equation is the specific heat. The change in temperature with the bigger number minus the smaller number always. The first thing we do is the subtraction problem. So 92.5 minus 65 gives us 27.5. And then we can do the whole problem. And here's the answer we get, 185.02 grams, which we can just call 185. Okay, so there's one more example, example 4 on the next page that I would certainly look through, just so you have all the information. And then when you get to class, you will practice using these 3 versions of the initial basic equation until you feel comfortable.